Good morning, student. Last time I have explained about the application of derivative. First exercise always be removed because according to the new latest syllabus. So I just started from the 6.2 exercise. So last time I have explained 1, 2 and 3 question. Fourth you have to do according to the last lecture. Just I am giving the new types of question, that is start from 5th, 6th and along with more question. So I just giving you 5th question at which we have to find out the 6th question. Question number 6. Question number 6E. 5th as it is you can do according to this. I am giving only a 6th question E part, that is complicated for the calculation. So according to this one you have to find out the 5th question, 6th question and other more 7th, 5th and 6th, 4th, 5th and 6th. These are all the question are same, just you have to find out the intervals only. How can we find the intervals? How can we derive the result? So just I am solving the 6th. According to this base you have to do 4th, 5th and 6th all parts. Okay. Now just giving you find the interval in which the function is strictly increasing or decreasing. It means you have to find out the intervals at which intervals the function are increasing, at which interval function are decreasing, strictly decreasing. So just we decide one by one. Question is given, the function is given you fx equal to x plus 1 whole cube and into x minus 3 whole cube. Just you have to find out the derivative by using the product rule. That is the first function and the second, u into v. You can use this one. First as it is second derivative plus second as it is first derivative. Okay. In this way we can find the derivative, that is the first derivative. So x plus 1 whole cube, first as it is derivative of this one, you can see that x raised to the power n according to the x raised to the power n. So 3 will come here and the derivative of this one n minus 1 into x minus 3 derivative also will come, but we are not mentioning here since x derivative of x minus 3 1 x derivative of x is 1 and the derivative of minus 3 that is 0. Okay, so there is no need to write, only I have write only these two terms. No need to write the third steps, same as for the second one also. So okay, so this one as it is. Now derivative of this one 3 will come back side and this will be reduced 1 power minus x minus 3 whole square into this one also another function. We have to find the derivative, but that will be 1 minus 0, so no need to write here. So accordingly, similarly the second as it is first derivative of this one, you can see that 3 will come there and the power will reduce 1, that is 2 and minus 1. Okay, so now just simplify that. We can see that there is common portion is x minus 3, both are x minus 3 and both have x plus 1. So we have to take common with minimum power is x plus 1 whole square, x plus 1 whole cube. So that is common, that will common. 3 also both side common, x plus 1 whole square, that common. X minus 3 also whole square, that is cube. So minimum power will be square. So what will left in the bracket? You can see there will be x plus 1 and there is a x minus 3 here. So 2x minus 2, that will simplify that 2x minus 2. 2 also common here in both sides. 2 will come along with 2 3 is 6. 6 will come here and the final derivative will come after the simplification. You will get this function, that is the first derivative of the given function. To find out of the intervals for any function, we have to find out first critical points. What are the critical points? How can we find out? So for critical points at which function will be 0, at which point the given f dash x first derivative function will be 0. So you can observe that is the f dash at which point will become 0. If we put here 1, that will become 0. If we put here 3, that will become 0. At which if we put here minus 1, that is the 0, that will be 0. So there are 3 points you can observe, 1, 2 and 3. Otherwise you can see that at which point you can find out also as it is. It x plus 1 equal to 0, that will x equal to minus 1. Okay, x equal to minus 1. If x minus, that is the first point, sorry, x equal to minus 1. That is the first point. If x minus 3 equal to 0, it means 3. So that is the second point. If x minus 1 equal to 0, that will x equal to 1. So these are 3 points at which the function first derivative function will be 0. For a critical point, a point at which will function f dash x will be 0. That is these are called the critical points. So we have 3 critical points, minus 1, 3, 1. It means a function first derivative will turn at these points. So for critical points which will be 0. So we observe that critical points are x equal to minus 1, 3 and 1. Okay, minus 1, 3 and 1. These are the critical point for x. Function is given in x, so we have to find out the value of x at which the function first derivative will be 0. So we have to mention on the real number line. Just if we draw the real number line and we put these 3 points, minus 1, 3 and 1, you can observe that minus 1 will come here. There will be minus 1. There will be minus 1, or there will be 1, and there is 3. There will be 3, and there is minus infinity, and there will be plus infinity. Now you can find out the interval. How many intervals you can find? That is the first interval, that will the second interval, and that will be the third interval, and that will be fourth interval. So these interval divide the real number line into 4 disjoint sets. You can see, or other you can say 4 disjoint part. First part, second part, third part, fourth part. So we have intervals minus infinity to minus 1. First part, comma. Next interval minus 1 to 1. Third part 1 to 3. That is the first part. You can see that is the first. That is the second. That will be a third. That is the fourth interval. Minus infinity to minus 1. Minus 1 to 1. First interval, second interval, 1 to 3, third interval, and 3 to plus infinity. That is the fourth interval. Okay. So we can observe there we have intervals fourth. In these intervals we have to check which are increasing or at which interval function first derivative will be increasing or decreasing. So just discuss one by one. First one, for decreasing function, if f dash x less than 0. That is the condition for, last time I have explained, if f dash x less than 0, function will be decreasing. If f dash x greater than 0, that function will be strictly increasing or strictly decreasing. That is the strictly decreasing, or for strictly increasing, f dash x greater than should be 0 for strictly increasing function. So first we take that which the function is decreasing, strictly decreasing. For strictly decreasing, f dash x less than 0. F dash, what the value of f dash x? This one. This is the value of f dash x. You can observe that is the value of f dash x. So it means f dash less than 0. This way, in place of this one, we put the value of f dash x should be less than 0. So you can observe that is the 6 is a positive number. That is the square of any real number will be a positive also. This will always be a positive. This will always be positive. This will be positive or negative according to the value of x. So this all value depend upon this one only. Since these 3 values always be positive, so there is no effect of these 3 value. Affected or only one interval, that is the one term, that is the x minus 1. So only x minus 1 is the term that gives the positive or negative value. Hence whole value will depend upon this part, this term x minus 1. So it means x minus 1 less than 0. If x minus 1 less than, this always be positive. There is no need to mention all these terms. Only we have to find out the nature of this term, that will decide increasing or decreasing. Only this upon derivative. So x minus 1 less, if x minus 1 less than 0, that the whole derivative will be negative, less than 0. If this one is positive, the whole derivative will be increasing function. So first we take for decreasing, so x minus 1 less than 0, according to this one, there is no need to write here. This will always be positive. That is depend upon the function on this term only. So there is no effect of these terms, first 6x plus 1 or x minus 3, because this is a square, perfect square, that is also a perfect square, this is also a positive number. So that will always be positive. This value always be positive for increasing or decreasing. There is no change on this one. That is affect only this value will be defective, whole value will be affected by x minus 1. If x minus 1 less than 0, that function will be decreasing. If x minus 1 greater than 0, that function will increasing. So we can discuss here. So I interval from x, it means x minus 1 less than 0, x less than 1. So in intervals from line, yet x equal to 1. For what interval we need? Intervals from line at x less than 1. So you can observe x less than 1. How many intervals? Less than 1. Yeah, less than 1 means left side of 1. So how many intervals? First interval and second interval. What are the interval? Minus infinity to minus 1 and minus 1 to 1. So you can see minus infinity to minus 1 and minus 1 to 1. These are interval at which the function is decreasing. So overall we can say minus infinity to 1. We can say also this is the interval. These are the interval at which the function, first derivative function will be decreasing. Okay, these are the intervals. Now for increasing function, similar, same as process. F dash x greater than 0, in place of put the value, at which value the function will be positive or negative. It depends upon, this will always be positive. There is no effect. Only give the positive value upon or negative, that will depend upon here. So we need only increasing, so it means that should be greater than 0. X minus 1 greater than 0, it implies that x greater than 1. It means greater than 1, the value at which the value greater than 1 always be increasing. So greater than 1 means 1 to 3 and 3 to infinity. There are two values, true interval 1 to 3 and 3 to infinity. These are two intervals at which the first derivative will be increasing. So we can say that f(x) is increasing in interval 1 to 3 and 3 to infinity. Overall we can say 1 to infinity. Okay, in such a way we can find out the interval. So we learn about this question. We learn from this question that how can we find out the interval. So first we have to find out the derivative and then find the critical point. Second step. First step is we have to find out the first step. What the first step? First we have to find out the first derivative. So in this way, and then simplify it. After simplification, you have to find out the critical point. Critical points are those points at which the function of first derivative will be 0. So you can find out in this way. At all critical points we can find out using this process. Either you can directly put minus 1, 3 and 1. These are the point at which if we put minus 1, that will whole 0, that will become whole 0. If we put the 3, that will become whole quantity will be 0. If we put the 1, that also then the whole value will become 0. So these are the 3 points, and we mention on the real number line, and you have to find out the intervals, how many intervals, and just you have to check out the interval by this way for decreasing and increasing according to less than 0, f dash x less than 0 or greater than 0. Is that clear? Okay. Now let us start the next question. Question number 7. Y equal to log of 1 plus x minus 2x upon 2 plus x. Okay, this is the question. X greater than as increasing function, x greater than minus 1 increasing function throughout the domain. Throughout the domain. So how can we find out just we have to, what the process of the increasing function? It means that x greater than minus 1, that is also a interval. You can say that x greater than means what does it mean? X greater than means minus 1 to infinity. So you have to check, you have to prove that, what we have to do? Prove that, show that, or prove that, show that you have to show in this interval this function is increasing. So you have to find out this value according to this one. If x greater than -1, that function will become a increasing function. So we have to check, or we have to find out one as it is. First, what the process is? First we have to find out the first derivative. First derivative means that is the fx. So dy by dx. First derivative is dy by dx. What is this? What the derivative of log 1 plus x? 1 upon x plus 1 into 1 plus x. Another derivative by using the chain rule. One is derivative of 1 will be 0, and value of 1 is, you can see that derivative of 1 is 0 and x is 1. So no need to write log 1 plus x, 1 upon x plus 1, and the derivative of this one will be 0, this one. So there is no need to write of this one only. So there is no affected by this. So we left this part. So just come to the next one. That is you have to derive by the quotient rule. This is the quotient rule. How can we find? In this way you can say that is the numerator and denominator. So how can we find the quotient rule? What the rule of quotient rule? Denominator as it is into ddx of numerator. What is the numerator? 2. Derivative of this one is 2 minus numerator as it is into derivative of denominator, that is the 0 plus 1, okay, upon square of denominator, okay. लिख ही देता हूँ पूरा. Okay, in this way we can find out the derivative of this one upon x plus 1 into the derivative here 2 plus x by the quotient rule into derivative of this one 2 minus numerator as it is into derivative of denominator 0 plus 1 upon square of this one. Okay, in this way you can find out 1 upon 1 plus x minus, simplify it to 4 plus 2x minus 2x upon 2 plus x whole square 1 upon 1 plus x minus, this one cancel me, 4 upon 2 plus x whole square, just taking the LCM, 2 plus x whole square minus 4 into x plus 1, okay, that will be 1 plus x into 2 plus x whole square four plus x square plus 4x minus 4x minus 4, that will be 1 plus x 2 plus x whole square. you can see that 4 is 4 cancel, 4x will be cancelled, that will become x square upon 1 plus x. Okay, so we can see that dy by dx equal to x square upon 1 plus x 2 plus x whole square. So what they observe, so critical point will be x equal to 0 only, that will always be positive. You can observe that this will always positive, this value always be positive, either x negative or positive or anything. So that will only depend upon this one. So we can observe that for increasing function, for increasing function f dash x should be greater than 0. Okay, this will always be positive, this always be positive. Increasing and decreasing depend upon this term 1 plus x, only this one. So it means x square I, you can say implies that I x square upon 1 plus x into 2 plus x whole square should be greater than 0. Okay, that will always be positive, this will always be positive. It means implies that it means depend upon 1 plus x should be greater than 0, depend upon this one only term. This always be positive, this always be positive, and the value of increasing or decreasing that depends upon this one. So what have to find? Increasing. So we have to increasing, it means this value should be greater than 0, so that whole function will become greater than 0. So 1 plus x greater than 0 implies that x greater than minus 1. That is proof. Hence we can say, so hence we can say that given function is increasing in x greater than minus 1. Okay, that is proof. So we have to show only this one. Question number 9. Prove that y equal to y equal to 4 sin theta upon 2 plus cos theta minus theta an increasing function of theta in 0 to pi by 2. Okay, this one given you. So prove that this function is the increasing function for theta in 0 to pi by 2. So we have to, it means we have to find out the interval. You can, if we show just last question, previous question, I have also mentioned that x greater than minus 1, just we have to find out the interval. Similarly, we can find out the interval at which if we prove that this one is positive in this interval, if we prove that this whole function will be positive in 0 to pi by 2, the function will be increasing. So how can we prove that this will be positive? That if the derivative of this one is positive, that whole function will be increasing function in between 0 to pi by 2. So let's come on this way. First we given, so dy by dx, what will come? This one is another function, this one is another. We have to do the derivative of this term as separately, these two terms separately. That will come in by the quotient rule. You have to apply the quotient rule. How can we do? Denominator as it is 2 plus cos theta into derivative of, you can see derivative of numerator 4 sin theta minus numerator as it is into derivative of denominator upon square of denominator. Okay, square of denominator. So how can we find? Just simplify it. Find out the derivative. 2 plus cos theta. Simplify it. 4 sin theta means minus 4 cos theta. Okay. 4 sin theta. And derivative of this one 0. 2 is the 0. Derivative of 2 is 0. And cos theta is the minus sin theta. Here also minus theta also here. Okay. So that is the separate value. You can separate here. Minus theta is also another one. That is another function. Minus theta will be another terms. That is the derivative of first term and the derivative of this one. ddx of theta. 2 plus cos theta whole square, that will be 1. Yeah, multiply, simplify it. Minus 8 cos theta minus 4 cos square theta plus 4 sin square theta. By taking the LCM, you can see that 2 plus cos theta whole square upon 2 plus cos theta whole square. So taking the common 4, minus here will be minus will come. Okay. So minus 8 cos theta minus, taking the minus 4 common, what will come? Cos square theta plus sin square theta. You can open this one. 4 plus cos square theta plus 4 cos theta. Upon 2 plus cos theta whole square. Just simplify it. You can see this value will be 1. Minus 8 cos theta sin theta will be positive, huh? Derivative sin theta will be positive. 4 cos square theta, and this or minus will be positive also. Eight cos theta plus 4 minus 4 minus cos square theta minus 4 cos theta upon 2 plus cos theta whole square. Okay. Now we can do in this way. 8 cos theta, this will cancel out. 8 cos theta minus 4 cos theta. 4 cos theta minus cos square theta upon 2 plus cos theta whole square. square. We take the common cos theta, will we take common 4 minus cos theta upon 2 plus cos theta whole square. That is the first derivative, or you can say f dash x, this one. For increasing function we have to prove that this will be positive. How can we prove that? You know that cos theta will be highest value is plus 1 and minimum value is minus 1, so this always be positive, since cos theta always lie between minus 1 to 1. So these two values are less than 4, so this will be positive. That will be positive, this value. This will be also a positive, because of perfect square, the whole square always give the positive value. That depends, positive and negative depend upon this value. So for increasing f dash x greater than 0, it means that should be greater than 0. Okay, that should be greater than 0. So this always be positive, this always is positive, so that is positive or negative not depend upon these two terms, that depend only cos theta. So we can say that cos theta should be greater than 0. Okay. So another way you can say here also, cos theta into 4 minus cos theta upon 2 plus cos theta whole square greater than 0 implies that cos theta greater than 0. Okay, and cos theta 0, we can say that in interval 0 to pi will always be positive. So we can say that f of x increasing in 0 to pi by 2, since cos theta always be positive in between in the interval 0 to pi by 2. You all know that first quadrant, that will lie in, that will cos theta always be positive in the first quadrant. First quadrant means 0 to pi by 2. So we can say that the whole function will be greater than 0 or increasing function in the interval 0 to pi by 2. Okay. On the basis of this one, you have to do the remaining part. If you have any problem, you can ask me, give me a message, so that I can deliver in the next video. You can ask a question by message or comment box, so that I will be able to do according to your problem. Okay. If you don't ask, then I will come to the next exercise. Okay. So just you have to do today itself. If you have any problem, you can ask me anytime by giving the comment. So you have to do today itself. Okay. Next time I will be explain more about this one, on the solution of this one or problem on this one, and come on also do of our next exercise 6.3.